How do you give an AI application memory? How do you make it understand your specific data? The answer is embeddings and RAG, and today you're going to master both. Welcome back to the Open Source AI Stack 2025. This is episode 2, and wow, the response to episode 1 was incredible. Thank you all for the amazing comments and questions. Last time, we built our foundation with front-end frameworks and orchestration. Today, we're adding intelligence. We're exploring embeddings, the technology that converts text into mathematical vectors that machines can understand. Then we're diving into RAG, Retrieval Augmented Generation, the technique that lets your AI access and use your specific data. We'll cover Nomic Embed 2, BGE Model 3, and E5 Mistral 7B for embeddings. Then LlamaIndex, RAGFlow, and Haystack for building RAG systems. Plus, we're looking at backend infrastructure, vLLM, Ollama, and LiteLLM, the tools that serve your models efficiently. This is where AI gets really powerful. This is where your applications become knowledgeable. Let's do this. Layer 3, Embeddings. Layer 3 is all about embeddings and RAG, Retrieval Augmented Generation. This is how we convert text to vectors and build systems that can search through vast amounts of information. Nomic Embed 2 is a breakthrough. It's the first open-source mixture of experts text embedding model that achieves top performance on MTEB benchmarks while being fully reproducible. With an 8192 context length and open weights, it's setting new standards. BGE Model 3 is your multilingual powerhouse. It supports over 100 languages and handles dense, sparse, and multi-vector retrieval all in one unified model. If you're building global applications, this is essential. E5 Mistral 7B leverages the power of decoder-only LLMs for embeddings. With 7 billion parameters and a massive 32,768 context length, it excels at instruction following and retrieval tasks. It's proof that bigger can be better when it comes to understanding semantic meaning. RAG frameworks. Now let's talk about the frameworks that make RAG practical. LlamaIndex is the most comprehensive data framework for LLM applications. With over 150 data connectors, advanced query engines, and agent capabilities, it's like a Swiss Army knife for RAG. You can connect to virtually any data source, databases, APIs, documents, you name it. The evaluation framework helps you measure and improve your RAG performance continuously. RAGFlow brings a visual workflow builder to the table. It combines document understanding, chunking strategies, and retrieval in one platform. The visual interface makes it easier to design and debug your RAG pipelines. Haystack from DeepSet is built for production. It's an end-to-end NLP framework with a pipeline architecture, multimodal support, and automatic REST API generation. If you need enterprise-grade RAG, Haystack delivers. Layer 4, Backend. Moving to Layer 4, Backend and Model Access. This is where we serve and access our LLMs efficiently. vLLM is a game changer for LLM inference. It uses paged attention for efficient memory management and continuous batching for high throughput. The result? You can serve models faster and handle more concurrent requests. Plus, it's OpenAI compatible, so integration is seamless. Ollama has democratized local LLM deployment. With a simple CLI, you can download and run large language models on your machine. One command to pull a model, and you're ready to go. GPU acceleration included, and it supports over 100 models. LiteLLM is brilliant for flexibility. It provides a unified interface for over 100 LLMs, GPT, Claude, Gemini, and open source models. You get load balancing, fallback routing, and cost tracking all in one package. It's like having a universal adapter for the LLM world. Backend continued. Continuing with backend tools, FastAPI is the modern standard for building Python APIs. Based on standard type hints, it generates automatic documentation and validates inputs using Pydantic. The async support means you can handle thousands of concurrent requests efficiently. OpenRouter is your multi-model gateway. Access over 100 models through a unified interface with automatic failover and cost optimization. Compare models side by side and optimize your costs across providers. And TGI, text generation inference from Hugging Face, is optimized specifically for serving Hugging Face models. Tensor parallelism, flash attention support, and Prometheus metrics make it production ready. If you're deploying Hugging Face models, this is your best friend. The pattern here is clear. We're moving from monolithic systems to flexible, composable architectures where you can swap components as needed. And there you have it, the intelligence layer decoded. Embeddings transform text into vectors, RAG retrieves relevant information, and backend infrastructure serves it all efficiently. Use Nomic Embed 2 for best-in-class embeddings. Choose LlamaIndex for comprehensive RAG. Deploy with Ollama for local development, vLLM for production scale. Next up in Episode 3, vector databases and data storage. Where do we store all these embeddings? How do we search through millions of vectors in milliseconds? All that and more. Like this video, subscribe for the next episode, and let me know in the comments, are you running models locally or using APIs? I'm curious.